Ladies and gentlemen, let's take a look at this new vocabulary. Piecewise, and I honestly, and I say this, and I always put one too many things on my to-do list. Why they call them piecewise functions, I have no idea where that vocabulary comes from, other than it's a couple of functions that are pieced together. And so what a piecewise function is it's a set of functions, okay? We're going to primarily look at two different functions. And so what you're doing is you're graphing two functions at the same time. All right, but they're going to have kind of a boundary. It's kind of like, you know, back, have you guys studied the Berlin Wall? Separate East and West Germany. You guys gotten that far, like in this history and stuff? All right, so we're going to have these two functions, but there's a divide there. There's a sectioning of them, okay? And so you're only going to see one function on one side of the wall, one function on the other side. They're not going to continue all the way across the graph. We're going to graph that tomorrow. What we're going to do today is show you an example of why these piecewise functions actually exist. The other thing you're going to graph tomorrow is what's called a step function, and basically that's what their name is. They resemble steps, or a set of stairs. So you're going to have these steps that you're at, okay? Our pay has kind of been steps, because we get somewhere and we stay there for a really long time, and you finally get a raise, and then you stay there for a really long time. Okay? Your pay doesn't constantly increase at your job, right, guys? You may get a raise, but then you stay at that pay level for at least a few months, sometimes years, depending on what your job is. And then you bump up automatically to the next level. And so those are what we call step functions. All right? So let's take a look at what these piecewise functions look like. All right. When ordering tickets online for an upcoming concert, there's a $15 handling charge. Tickets are $25 each, or $20 each for groups of 12 or more. That is what a piecewise function means. We have one price, $25 per ticket, plus the $15 charge, if your group is less than 12. We are only going to pay $20 per ticket, plus the $15 handling charge, if your group is greater than 12. Ladies and gentlemen, how many of you ever bought something on discount when you buy it in volume? Bought something like, if you buy 3 or more, you get a price break. Buy 4 or more and get 1 free. That's a piecewise function. If I only buy 3 of them, this is the price I pay. But as soon as I buy my 4th one, I pay a completely different price. That's what a piecewise function is. And so you find it often in larger ticket items. The more you buy of something, the school will get discounts the more computers they buy. So if they buy under 10 computers at maybe one price, as soon as they buy 10 or more computers, they get a cheaper price. That's why we have these piecewise functions, because certain businesses want to get a greater volume in. So what we need to do is figure out which function we're looking at and use that function to evaluate our situation. So you only want to buy 8 tickets. Do you get the discount or not? No. So you're going to have to use the larger ticket price. The way to look at this, guys, is you look at how many tickets you're buying. Is 8 less than 12? Or is 8 greater than 12? All right. It's less than 12, so you have to pick the function that is using less than 12. And then what you're going to do then is to plug that in for x. So you're going to have 25 times 8 plus 15. And our ticket price should be $215. Can someone double check on this one? Is 8 times 25, 200? Now, what would you do if you're buying 16 tickets? Well, is 16 greater than 12 or less than 12? 16 is greater than 12, so I need to pick the greater than function. 16 is still my x. It's the number of tickets I'm buying, because it's $20 for each ticket. So 20 times 16 plus the $15 handling fee, $320. Can someone double check the math from their calculator? Is it $335? Or maybe even in the head? Is it $335? All right. Do you guys understand how to read this piecewise function now? If your x value is less than 12, you're going to evaluate this function. If your x value is greater than 12, you're going to evaluate this function. All right. Well, ladies and gentlemen, let's take a look at the next screen. All right. Now what we're going to do is we're kind of stepping away from some of the word problems and just getting into rote evaluation. We want to evaluate when x is equal to -3 and when x is equal to -1. What my function says is I'm going to take x minus 4 if x is less than -1. I'm going to take 3 times x minus 1 if x is greater than -1. -3, is it greater than -1 or less than -1? Which is it? It's less than. Be careful, guys. If it's to the left, then it's less. So picture these on a number line. Here's -1, here's -3. So because it's to the left, it's less. So I'm going to plug -3 in for x in only that first function. There's 2 functions here, but only one of these is going to work for my given x value. Just like I didn't want to plug 16 into the first function, did I guys? I only wanted to plug it into one of those 2 situations. It's the same thing here. I'm only going to want to plug that into one of those 2 situations. So I'm going to take -3 minus 4. That equals -7. So we're going to go back to using our function notation, ladies and gentlemen. The function at -3, this will always be your x value, equals your output of -7. So we looked at our piecewise function. We looked at that boundary. Our wall is at -1. My values are either less than -1 or greater than or equal to -1. And I picked which of those 2 functions my x value fell into. We said -3 was less than -1, so I plugged -3 into just that function. All right, -1. Is it less than 1 or greater than or equal to 1? Well, we need to be careful, guys. This is my boundary, isn't it? -1. This is the break that they told me. I'm either going to be less than -1 or greater than or equal to -1. If I'm at -1, you have to pick the one that says equal to. Okay? -1 is not less than -1. -1 is not greater than -1. -1 is equal to -1. So you have to pick which one has the equals to. One of these will always have the equal to -1. All right? So we're going to plug it into the second function. 3 times -1 minus 1. Type that into your calculator. Use your mental math. -3 minus 1 is -4. So how am I going to write my final statement using my function notation? F of -1 equals... Beautiful. All right, ladies and gentlemen, I want you guys to do on your own. We now have 3 of them. You got G at -4, you got G at 7, and you got G at -12. Your piecewise function is, I'm going to use -3 times x minus 4 if my x value is less than or equal to 3. I'm going to use 2x plus 5 if x is greater than 3. You need to pick which category each of those goes into, then evaluate those. All right?